Hi, in this video lecture, we're going to learn a HackerRank problem titled Insert a node at a specific position in a linked list. Let's read the question and understand what we need to do. Given a pointer to the head node of a linked list and an integer to insert at a current position, create a new node with a given integer as its data attribute, insert this node at a desired position and return the head node. So it will be giving us the head pointer to the list. It will be passing on the data and the position. We need to create a node and then we need to insert a node at a specified position. It also says that a position of 0 indicates head, a position of 1 indicates one node away from the head, and so on. The head pointer given may be null, meaning that the initial list is empty. If the list is empty, we need to insert that element as the first element, and in case if the position is 0, that in that case we need to insert it again at position 0, which is the same as insert at the front. One simple example has been provided out here. Head refers to the first node in the list, which has 3 elements, 1, 2, and 3. The data portion is 4 and the position is 2. Now position of the head will be 0, so this is at position 0. Okay, and this is at position 1 and this is at position 2. So I need to insert a new node at this particular point, okay, wherein the data portion of the new node will be 4. So I need to create a node, and after that I need to insert at this position. When I say insert at this position, it should be after 2 and before this 3. So this 2 should point to 4 and the 4 should point to 3. The final list should look like this: 1, 2, 4, and 3. It should look in this particular fashion. So let's try to write the code for this. Yeah. Here, we don't need to really write the code to read n values and then insert n elements. Only thing what we need to do out here is there is a function provided. We need like insert node at position. We need to complete that particular function. That's it. And what's the function name out here? The function name out here is insert node at position. It has 3 parameters. First one is a pointer to the head node. It might also be mentioned as ls in some cases, data, and the position. So let's start implementing the code. The first thing is create a node. How do we create a node? By allocating the memory dynamically. And for malloc, we need to specify the size of the node. I'll capture this type, and then this will reserve the memory for the node, and which I need to capture it into a pointer. I'll try to capture it into a pointer called as new node. And yes, the typecasting here is optional. And yeah, any memory which is allocated dynamically can be successful or a failure. I'm assuming that it is successful and proceeding further. Once the memory allocation is done, I need to initialize the node. The data part of the node section should be set with the data, whatever we have passed as a parameter. And the next part, which is a pointer pointing to the next node, should be set as null. So this portion will create a node as well as it will also initialize the node. Now I need to look into inserting that node at the list. So first condition is I'd like to check out if the list is empty. Like for example, if head equal to null. So in that particular case, the newly created node itself is my head node. So I will try to just say head equal to new node, and then that's it. There's nothing more to be done. I can just try to write return head. Okay. If head is not null, then if position is 0. See, I'm not writing this else part here because I know if this condition is satisfied, I'm using in return. So I'll try to return back. Okay, if you're not writing a return here, if you're trying to return only at the end, in that particular case, we need to use an else here, right? Okay, so if position is 0, it is same as insert friend. And remember, the list is not empty. If the list is empty, you would have completed with this itself. It has come to this point. It means that the list is not empty, but the position is 0. So in that particular case, I would like to make the next pointer of the new node point to the head. And then I'll update the head telling that the new node will be my first node. Again, after that, my job is done. So I'll try to return this. Okay. So I've taken care of position 0 as well as the list is empty. But in case if the list has some elements and the position what you want to insert is not 0, then we need to traverse. We need to basically traverse to that particular position, and then we need to do the insertion. So to traverse this, what we need to do out here is we need to basically use a pointer which will go to the position point. And since this being a singly linked list, I can only move forward. Let's say, okay, I need to insert at this position 3, right? So if I have to insert at this position 3, if I bring a pointer which is okay, reaches to this particular point, now I need to modify the link of 2. Remember, once you reach here, you cannot go backward. You cannot go backward. So for that purpose, I will be requiring additional pointer. So initially what I'll try to do it is I'll try to have 2 pointers. One pointer, let us say called as current, will be pointing out here. One more pointer called as previous, which will be okay pointing one step previous to this. Then I will update this particular pointer. How many times? Position number of times. One time I'll bring in this here. I'll try to bring in here, this here. Then I'll try to bring in this here, and then I'll try to bring in this here. 2 times I've jumped. After 2 times, you can just see my current pointer is here, my previous pointer is here. Once you reach to this point, I would like to just modify the previous pointer, point to the new node, which has the data portion as 4 in this particular case. And then, okay, the next portion of the new node will point to wherever the current pointer is. Okay, so this is what I would like to basically do out here. So I need to traverse position number of times. So I just go to this code out here, and then I require 2 pointers. Both the pointers will be of the same type. There is a pointer to the node. I'll just say that pointer to previous node, and then this I'll just set it to null, and then I'll also use the pointer to current node, which will be pointing to the head pointer. Then I need to do the traversing. So for traversing, I'll try to start this I equal to 0, I less than position, I plus plus, and I will update. Remember, before you jump the current pointer, bring the previous to the current position. So I'll just try to write PTR of previous equal to PTR of current. So once the previous pointer comes to the current position, then the current pointer will jump one step ahead. So I'll just say PTR current equal to PTR current of next. Okay, so this way it basically jumps to next node. Now once okay, I reach to the position, I need to modify the link. I need to modify the link portion or the next portion of this previous node to the new node, and I need to set the next portion of the new node point to the current node. And if this is done, I need to return the updated head. See, I'm trying to return this head at multiple places. If you want, you can just try to return only one place. In that particular case, you need to write the else parts out here. First, let's try to run this particular code and verify if it's passing the sample test cases. And yes, sample test cases are passed. And then we will try to submit this. All the test cases are passed. Okay, so here is the code out here. But if you feel that no, I don't want to return at multiple positions here, I can avoid this. So in that particular case, remember, even if this is true and if you have executed, it can still jump in here. For that purpose, I'd like to mention this in the else part the same way. And if okay, you want to remove this, in this particular case, again, after executing either this one or this one, right, one of that, it might still come to this place. So I'd like to write an else portion here. And in the else portion, I'd like to write all this particular code. And finally, whatever is the updated value of the head, I would like to return the updated value of the head once. That's it. So this is the overall code out here. I'd like to run this and submit this code. So I hope the concept is clear. Thank you.